This is section 6-8, the rational zero theorem. Our objective today is I can find all possible rational zeros of a function, and I can find all of the zeros of a function. Now our first objective is going to be dealing with the first section of 6-8 notes you have. The second objective is going to be dealing with the part 2 of the 6-8 notes. So I've just made one video for all of the 6-8 notes. On example 1, we're identifying possible zeros. We have to list all of the possible rational zeros of each function. So, the way that we're going to do this, we have a special formula we're going to use. We're going to use P over Q, where P is going to be talking about the constant term, factors of the constant term, and in this case 16 is the constant term. So I'm just going to write 16 next to our P. And then Q is going to be talking about the factor of the leading coefficient. So we want to look for the largest coefficient. And if we look, we see that 4x to the 5th has the largest coefficient. So we know that our Q value is going to be 4. So now we need to list out all of the possible factors of P and all of the possible factors of Q. So the possible factors of 16 are plus minus 16, plus minus 1, plus minus 8, plus minus 2, and plus minus 4. The plus minus has to be there because we could do 16 times 1, or we could also do negative 16 times negative 1 to get positive 16. The factors of Q are going to be plus and minus 4, plus and minus 1, and plus and minus 2. So in order to write down the possible rational zeros, we have to do every single combination of our P with our Q in fraction form. So if I write these out, I'm going to have plus or minus 16 over 4, plus or minus 16 over 1, plus or minus 16 over 2, plus or minus 1 over 4, plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 8 over 4, plus or minus 8 over 1, plus or minus 8 over 2, plus or minus 2 over 4, plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 4 over 4, plus or minus 4 over 1, and plus or minus 4 over 2. So that's all of the possible combinations that there can be, and now all we have to do is simplify. So anything that repeats, we can get rid of. So plus or minus 16 over 4 is going to reduce to plus or minus 4. Anything that's equal to 4 we can get rid of. Plus or minus 16 over 1 is just going to be plus or minus 16. Plus or minus 16 over 2 is going to be equal to plus or minus 8. Plus or minus 1/4 doesn't reduce, so we have to leave it as 1/4. 1 over 1 reduces to 1. 1/2. 8 over 4 reduces to 2. 8 over 1 reduces to 8, but remember we already have an 8, so we don't have to worry about writing that again. 8 over 2 reduces to 4, we already have that one. 2 over 4 reduces to 1/2, we have that. 2 over 1 reduces to 2, we have that. 2 over 2 reduces to 1, we have that one. 4 over 4 reduces to 1, we have that. 4 over 1 reduces to 4, we have that. And 4 over 2 reduces to 2, which we also have. So our possible rational zeros are plus or minus 4, plus or minus 16, plus or minus 8, plus or minus 1/4, plus or minus 1, plus or minus 1 over 2, and plus or minus 2. Let's try a second example. So we know we're looking for P over Q, and P is talking about that constant term. So in this case, 12 is our constant term. Q is talking about factors of our first term, our leading coefficient. And in this case, it's just going to be 1. So if we write out possible factors, we're going to have plus or minus 12, plus or minus 1, plus or minus 6, plus or minus 4, plus or minus 3. And for 1, we're just going to have plus or minus 1. So if we list all of these out, we'll have plus or minus 12 over 1, plus or minus 1 over 1, plus or minus 6 over 1, plus or minus 4 over 1, and plus or minus 3 over 1. If we reduce these, we'll have plus or minus 12, plus or minus 1, plus or minus 6, plus or minus 4, and plus or minus 3. So our possible rational zeros are written on the line down at the bottom. So in the first part of this section, we learned how to find all the possible rational roots of a function using P over Q. We're also going to learn how to find all of the zeros in a function, both rational and irrational. So let's look at the equation x cubed minus 2x squared plus 9x minus 18 equals 0. Using the rational zero theorem, we're going to find all of the possible rational zeros of the function. And I've already done that for you because we did that on the last two examples. So we end up with plus or minus 18, plus or minus 1, plus or minus 9, plus or minus 2, plus or minus 6, and plus or minus 3. Then we can see that based off of the fundamental theorem of algebra, our function that we're looking at is going to have 3 complex roots. And we know that because we can look at the largest coefficient that there's going to be, which is 3 in this case. We test our possible roots using synthetic division, and we're going to take a look at that on the next slide. So looking at those possible rational roots, we can go ahead and start trying these. So I'm actually going to start with positive 1. You can start with whatever number you'd like. So I'm going to try plugging 1 in. And I'm going to use my synthetic division. So I'm going to have 1, negative 2, 9, and negative 18. So if I go ahead and bring my 1 down, I have 1. 1 times 1 is 2. Negative 2 plus 2 is 0. 1 times 0 is 0. 9 plus 0 is 9. 1 times 9 is 9. Negative 18 plus 9 is negative 9. So this is not one of our zeros because we got negative 9. Let's go ahead and try a second one. Let's try negative 1. If we have negative 1, we're still going to do it the same way. We have 1, negative 2, 9, negative 18. And we can go ahead and bring our 1 down. Negative 1 times 1 is negative 1. Negative 2 plus negative 1 is negative 3. Negative 1 times negative 3 is positive 3. 9 plus 3 is 12. And 12 times negative 1 is negative 12. So we're going to end up with negative 30, which is also not 0. So this isn't going to be one of our zeros either. So let's go ahead and try another one. Let's try 2. If I try 2, I'll set it up the same way still. My 1 will come straight down. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 9 plus 0 is 9. 9 times 2 is 18. Negative 18 plus 18 does give us 0. So we know that this is going to be one of our zeros. So now that we know what one of our zeros is, we can go ahead and find the other ones. I'm going to go ahead and write x equals 2 down at the bottom so we know that that's one of our zeros. But we're also going to use our new equation, which is going to be x squared plus, it would be 0x plus 9. And we're going to be able to factor. So I'm going to go ahead and just write x squared plus 9. So then since this is one of our factors, we can go ahead and solve for x in this case. So we're going to just go ahead and say x squared plus 9 equals 0. We can subtract 9 from both sides. So we have x squared equals negative 9. And if we take the square root of both sides, we're going to end up with x equals plus or minus 3i. So over here, we know that x is equal to 2, x is equal to positive 3i, and x is equal to negative 3i. And those are all of our roots, imaginary roots at 3i and negative 3i, and then a real root at 2. And this goes back to where we knew we were going to be able to find 3 zeros, and we did find all 3 of them. So x equals 2, 3i, and negative 3i is our final answer. Let's go ahead and look at another one. So we're going to find all of the roots of x cubed plus 2x squared plus 3x plus 6. First we need to figure out the possible roots that there's going to be. And based off of this, we know we're going to look at p over q. So we're going to have plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, all over plus or minus 1. So our possible zeros are plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. So let's go ahead and start trying these, seeing which one works. I'm going to start with 1. So I'll have 1, 2, 3, and 6. Bring my 1 straight down. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Bringing it straight down. 3 plus 3 is 6. 1 times 6 is 6. And we end up with 12 as a remainder. So this one is not a 0. Let's try negative 1. With negative 1, we'll use the same numbers we used before. Bring our 1 straight down. Negative 1 times 1 is negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 times 2 is negative 2. 6 minus 2 is 4. So that's not going to work out either. Let's move on and try 2. One comes down. 2 times 1 is 2. 2 plus 2 is 4. 4 times 2 is 8. 3 plus 8 is 11. 11 times 2 is 22, and we know we're not going to get 0 as our remainder. We're going to get 28. So let's try negative 2. One comes down. Negative 2 times 1 is negative 2. 2 minus 2 is 0. Negative 2 times 0 is 0. 3 plus 0 is 3, and 3 times negative 2 is negative 6, which means our remainder here will be 0. Now sometimes you may have to try several of these. As you can see, I was just choosing some to try, and you may end up having to try all of these. Sometimes you may just get unlucky and the last one you find might be the 0. So now that I have the 0, I know that one of the zeros is negative 2. And now I want to figure out the rest of them. And so I have x squared plus 3 equals 0. I'm going to subtract 3 from both sides so that I have x squared equals negative 3. And if I take the square root of that, I can't take the square root of negative 3, but I can go ahead and bring an I out so that I have I plus or minus square root of 3. So our other roots are going to be I plus square root of 3 and I minus the square root of 3.